Finding the Laplace transforms of sine and cosine is probably the funnest thing I've done in the last 24 hours that involved math. So that's always kind of neat. It's kind of a neat little trick, and it makes you feel smart, and you figure it out, and then you get really frustrated. It's one of those things that gets really, really frustrating, and then you're like, this is never going to end, and all of a sudden it ends, and it's pretty. It makes you happy. So let's just get started. Enough talk. Let's do math. So let's say I wanted to find the Laplace transform of sine of omega t. 0 to infinity, e to the negative st, because that's the definition of a Laplace transform, sine omega t. Now, if you've ever integrated by parts with sines and cosines, you may or may not already know what's going to happen. All right, so I'm going to use integration by parts because I kind of gave it away. U, sine omega t, and my dv will be equal to e to the minus st, dt. Beautiful. So that means that du is equal to omega cosine omega t dt. And I'm running out of space because, motor planning is hard. And then 1 over st negative. There we go. And I can math. Yay, math. Okay. So I've got uv times 1 over s e to the minus st minus the integral of this thingy omega cosine omega t dt, and you're probably already getting a little depressed, but that's okay because depression inspires you to be better at math so that people will be impressed and excited about math. Alright, I got nothing. I'm sorry. I just do it because it's fun. I never understood why it explained to people while you were doing math. You're like, but doesn't it just satisfy your soul on some fundamental level because you're doing math and you're figuring out answers and they just look at you weird? And you kind of feel sorry for them because you're like, but how can you not be just desperately excited about math? I mean, it's math. It's like not liking puppies. It's weird. Okay. So 1 over s e to the minus st cosine. I wish this all fit on one line. I have the technology to make that happen. I think I will make that happen. That was just unnecessarily large. There we go. Okay. But since I do love puppies, I do love math. The two are inextricably linked. All right, as t goes to infinity on this one, this is something we've seen a whole lot. Sine goes from -1 to 1. This is going to get huge. So even a number between -1 and 1 divided by something huge is just eventually going to be 0. Sine of 0 is, in fact, 0. 1 over s, and some part of you should recognize this. Maybe not recognizing what the actual answer is, except the fact that I forgot my limits, but knowing that this is, in fact, the, This is the Laplace transform of cosine of omega t. And you're like, this is stupid, because you just gave me sine in terms of cosine. I know. It's part of the fun. But if you've ever integrated by parts on sines and cosines, you should probably know this is going to happen. All right, so let's find the Laplace transform of cosine. Cosine omega t. So, anyone do anything fun this weekend? I did Laplace transforms. It was fun. Made lots of friends. I integrated by parts. So you should pause the video, see how far you can get on your own, and that way you don't have to watch me do stuff and listen to me talk about how much I love math and puppies. Okay. This is really boring. Mostly for you, not for me. I'm having a blast. I just feel bad for you, because you have to listen to me do math. Kind of weird. It's like watching someone knit, which I guess is interesting if you're into knitting. Stream of consciousness is not a good idea when you're doing YouTube videos. Minus integral. I don't know why I've chosen to make you watch all this. Ooh, we have another negative sign. That's crazy. Look at the action. Okay, now things are getting good. Okay, so minus 1 over s cosine omega t e to the st evaluated as t goes to infinity. minus, omega t, cosine omega t over e to the st as t goes to 0. All right, minus, minus, minus. Man, we're going nuts. And I'm going to put the 1 over s out front. Ooh, there's an omega on there too. Whoa. Crazy. Okay. Sine omega t dt. My handwriting is getting messy because, I already know the answer. So that's all that matters, right? Okay. Now in this one again, we have starting off negative 1 over s, and this infinity thing is going to make this part here go to 0. Now this is where it gets a little bit crazy. What's the cosine of 0? The cosine of 0 is 1. And then we have on the bottom e to the st, which is 1. Look, something new happened. Except on the right, we ended up with, you guessed it, the Laplace of the sine of omega t. So we've got 1 over s minus omega over s sine t, like that. So this is fantastic because basically what we've done is I've shown you that the Laplace of the sine of omega t, and I know I'm writing all this out again, but that's okay, is equal to this. But I've also shown you that the Laplace of cosine of omega t is equal to this. And you're like, isn't that silly? What do? I just keep flipping back and forth? Well, kind of. Or you could be super smart and realize that you could make a simple substitution. So I know that the Laplace of the sine of omega t is equal to this. So I can just plug it in and do basic. Basic? I don't think it's really basic when you have Laplace transforms, but I'm doing essentially basic algebra. So I'm going to plug this in. It's omega over s, Laplace, cosine, omega t. Alrighty then. So it's a little time intensive insofar as the copying down the exact same thing over and over, but I think it's important that you learn stuff. So I'm willing to take that hit. S squared. There we go. Okay, now this is just like a regular term. So this is like x is equal to 1 over s plus this x. Okay? So I'm just going to add that to the other side, or add it to both sides, or whatever kind of algebra speak that makes you happy. So basically I have that 1 plus omega squared over s squared times the Laplace of cosine omega t is equal to 1 over s. Excellent. And because I'm kind of amazing at finding common denominators, I can then say that the Laplace of cosine of omega t is equal to, let's see, let me take an extra step just so that you can follow what I'm doing for sure. So that's what that would look like here on the left. So I'm just going to take the inverse of it, come here, and put it on the right. So I have 1 over s times s squared over s squared plus omega squared. So I have that the Laplace transform of cosine is actually equal to s over s squared plus omega squared. And you're like, but we were supposed to be finding the sine one, and why'd you find the stupid cosine one? You're like, I don't know, because I did. Lay off. So I'll get there. So I know that the Laplace of sine is equal to omega over s times the Laplace of cosine, which means that it is equal to omega s times s over s squared plus omega squared, except writing is hard. All right, and so finally I get that the Laplace transform of sine omega t is equal to omega over s squared plus omega. So again, you have lost the time domain. The time domain is no longer in there. You've got something that's only in the frequency domain. And these are actually very, very popular Laplace transforms. You're going to see these a whole lot. You'll be glad you watched this.